I'm Adam, and this is part, I don't know what, in one of my videos on how to install an access control system. In this video, we're going to be showing the connections, and the setup, the wiring on the door side. So I am at one of my controlled access doors, and I have chosen the Rosslare AY-H625BT reader. Been using Rosslare for a few years now. Really like their products, really like their support. It's a good price point. They pack a lot of features in there. They don't charge you for stupid licensing fees like some of the other big box, big brand name control planes do, where you have to license every workstation that you're going to run the controller from. Rosslare gives you the software, load it anywhere you want, as many times as you want, and they make a nice reader. This reader I particularly like because this supports Bluetooth. So it actually lets you utilize the Bluetooth chip in your Apple or Android phones to be presented as the credential. Nothing super special about wiring it. It does support OSDP. We are actually just going to use traditional Wigan, and I've got wires coming down the wall here from my control panel, and we're going to get started by soldering these guys together. This is my reader, and I'll pull the camera in here so you can see a little bit better. So we have soldered up our wires from our reader, and we could really get away at a minimum with 4 wires. We need power in, and then we need the Wigan data lines 0 and 1, which is the green and white. Our power is red, black. We've got ground, which is also shielding that goes around both of these cables. If you've got noisy environments, manufacturing, it's probably a good idea. I just generally always use shielded. And I've got one more wire here coming out of the Rosslare reader, which is orange. The orange line is a control signal for the green LED. So I like to hook that one up, so on a valid card swipe or Bluetooth ID, you get a green light with that control wire being connected. The rest of these on the Rosslare reader are used for different things. The color code is right on the back of the unit, so it will tell you. It's very small writing, but brown is the red LED, purple is a tamper, yellow is a buzzer, blue and gray are OSDP, and we are not going to be using that protocol. So we don't need to connect any of those wires. We're going to cut them, tape them off, and we're just going to go ahead and tape up all the rest of these connections, and then we'll make our way over to the panel. Give you one good close-up shot, just so you can see soldering that we did here. So all of our wires up inside here, and I did connect power to the unit so I could test it out and make sure that it was working. Also touched up our surround here on our electric strike from previous video. Came out looking really good. Fortunate enough that there is touch-up paint here, so you can see, looking at the edges, that I think everything came out very nicely on the strike. And we'll just take our cover to the unit here. Protective cover. And our reader is done. Here we are on the other side of our door, where we had just installed our electric strike and our card reader, and we want to wire up our request to exit button. So we've got our push to exit here. Well, logically, because of what we're using, there is really no reason why you should ever have to use this button. I've been told in some places that code requires it, but again, this being an electric strike, if you need to exit in an emergency, all you have to do is pull the doorknob handle. In the case of a mag lock, absolutely understand this would be a steadfast requirement that you have some way to release the mechanism in case, presumably, your PIR motion sensor did not release the door. But we're just going to do it just because, and for uniformity, and for all of our other doors we have one, so why not? So again, this is the Rex line in our multi-conductor cable that I dropped down this hole. We should have 4 conductors inside here. So we'll score this. Push mechanism from the button here, just to make this a little bit easier to deal with. It just twists off. If I really wanted to, I could also disconnect these quick connect terminals. Got everything soldered up, but notice we have an extra wire here that we're not going to use. I'm actually going to rearrange some of these here just to make the color matching a little bit easier. So our exit button can be normally open or normally closed. We want, at least the way I'm choosing to wire it, we're going with normally open. So when the controller sees these contacts closing, the green and the white wire, that is when it's going to trigger door release. So the contacts, really probably too small to see, but it is marked on the switch here which contacts are normally open and which contacts are normally closed. And there's our exit button. Wrapping up our access control installation here, and I've got a mess of wires hanging down from the ceiling. Want to talk a little bit about how this setup is wired here. We also have a PIR Rex exit device. So let's see if I can get a better shot of that. So there is our motion sensor for this door. What that device is going to do is going to allow you a much more natural pathway to exiting. You know, people are accustomed to the door being open as they approach it to walk out. If it was not for the PIR motion detector, this door lock, mag lock at the top, would remain engaged until someone were to depress the request to exit button that we have blocked by the ladder. So we've got a Rex button there. There's no reason why you can't have both devices. In fact, most installations do have both devices. So that is what we have wired up here. The PIR has 4 conductors run over to it. 2 of them are to power the device, and 2 of them are just to make a normally open relay contact short together. So it works exactly the same way that our request to exit button does back over here, in that when we depress our Rex button, the 2 data lines, control lines coming off of this switch are just shorted together. Those same wires are jumpered up and over to our PIR sensor, and it has a relay inside of it, and when it detects motion, it shorts those wires together. It looks admittedly like a giant mess of scary wires, but as you look closer, you can see that there's not that much to it once you break down the individual components here. So we're adding 2 doors to an existing panel here. The first door that we're adding will be the 4th door in the system. Those control lines are coming out of some multi-conductor cable that is right over here. Alright, so taking a closer look at the panel, like I said, this is going to be door number 4, the first one that we're connecting. These are the connections here for door number 4, and it's very difficult to see the markings on the board underneath, but there are markings here. This up top, these are inputs. You could hook up the door monitor to see that your door is open or closed on that first terminal. The second one is going to be the Rex input, or request to exit. So we're going to be using that one, and then the last set of terminals down there is the dry contact relay. That is the output, so that's what it's going to control. You've got common, and then you've got your normally open and your normally closed relay contacts. So what we will be connecting to for our first door, that's going to be a strike. And for our strike connection, we are going to want the normally open side of the relay contact, which means when the card swipes, that normally open becomes closed, and that will energize our door strike and allow the door to open. So a couple of things going on here. These are the wires from our strike. I've got a positive and a negative here. Negative is just going into a bundle with all my other negatives from the panel. The positive we're going to feed around here into our normally open terminal. Okay, that is our normally open. And what I had already done is I have a connection from the common here, which is going to be this terminal and this bundle. Common is going to a plus 12 volt source that's actually next to my cabinet. So I have this guy feeding the common. The reason that it's coming from outside of my panel is I've already got most of what can be supplied by my onboard power here consumed, and I like to be safe and err on the side of caution, so adding up all the amperages of everything that I have in here, I think I've hit the limit, the threshold of where I want to be for this onboard supply. So I've got that secondary unit feeding in a wire here at the top and coming in and hitting this relay contact. I've also gone ahead and connected it for my next door to the next set of contacts. So this is also going to be able to supply power to our fifth door, which is a mag lock. So that's all of our connections that need to be made on this side for our relay. This line here is coming from the card reader. So these are all our data lines for Wiegand and power to the card reader. I've actually already connected those, and it's simple. You're just following your color codes down. So you've got a black and a red. That's power to the reader. Then you've got your Wiegand data lines, D0 and D1. Those are green and white. And then this last line here, which is orange, this is going to the LED control on our reader, so that when we present a valid card, we get a green LED. And that's the reader line. The one remaining connection I have now is going to be from our request to exit for this door. So that's these two, and our request to exit is going to go into right here, the second and third screw terminals for door 3. So I'll go ahead and make those connections. Alright, so we're ready to wire up our fifth door, our last door now. At the top I've got all the wires coming in from that door. This is our maglock feed on this red wire. Our maglock is going to be connecting to the normally closed side of the relay. So we measure that wire out, snip it off, and into normally closed.